All right, welcome back everybody. We are going to take a look at inverse relationships today, and this is going to lead into our logarithms. So what is an inverse relationship? Well, let's take a look what a relation is in the first place. A relation is when a set of inputs have a distinct pattern with their outputs. So we've been studying that all year long. For example, linear relationships, also known as linear functions. So those inputs give you a set of outputs that when you graph them, you get a straight line. There's also quadratic relationships, so where the inputs there give you outputs that graph a parabola. And then exponential relationships we just studied, also known as exponential functions, that give you something that grows dramatically or decays dramatically when you graph the outputs based off of the inputs. An inverse relation is when the set of outputs will map back to the set of inputs. Wait, what? That means what was in the output table will actually give you what was originally in the input table, side of the table. So we're going to look at it in our three phases: a table, graph, and equation. So a table, let's take a look at our original relationship, and then take a look at what the inverse relationship should look like in a table. So we'll go with our standard numbers for our x or our independent variable. X, we go -2, -1, 0, 1, and 2. So those are usual numbers to begin with. So let's take a look at the outputs. So we got 4 to, 0, -2, -4. So that is a definite pattern there. We'll see the equation in a minute. So what an inverse relationship is, the numbers that were in the output are now the input, and they map back to the original input. So whereas in the OG relationship, the -2 gave us 4, in the inverse relationship, the 4 will now give us -2. So whatever equation for the OG, whatever it was, there's now a new inverse equation that will create 4 into a -2. And then take 2 to go back to -1. So if you notice, the y value in the OG is now the x value. And what was the x value are now the y values. Okay, if you need to pause and let that sink in, go ahead and do that. What we'll do next is take a look at the graph of an inverse relationship compared to its OG relationship. So here, we graph, see there's 5 yellow dots on that graph. They actually are the points from the OG relationship table. When we do this, when you try to graph the inverse relationship, you have to go back and use this linear function, x equals y. So that dotted line is x equals y. So if x is 3, that means y is 3. If x is -5, y is -5. That dotted line there is... Okay, so the x... Oh, sorry, I had to pause there for a second. So we take that dotted line. That is something that you're going to see will be useful soon. When you take the inverse relation, you plot those points. So look at those 5 points that are from the inverse relation table. So another straight line, and it has a certain relationship with those yellow dots. Those 2 yellow dots are reflected off that dotted line to become those 2 red dots. The yellow dot that was on the origin stays there as a red dot on the origin, and the 2 last dots are reflected to the other side of the x equals y line to become those red dots. So that what we have here is a reflection. So the inverse relationship will be reflected along x and y. And now let's take a look at it in its equation form. Again, I want you to watch these videos to get a sense of what we're going to talk about soon in class. So some of it you'll be able to digest and catch on quicker, hopefully in class, or have a deeper understanding when it comes to class time. All right, the equation. So the OG relationship and those yellow dots that are on that previous column were from this equation, y equals 2x minus 4. How do we find out what the inverse relationship is? Well, here are the steps to do that. This is our OG equation. What we're going to do here is you write it as x equals 2y minus 4. If you didn't catch that right away, which is fine, what we did was switch the x and y. So where the y was, the x is. And where the x was, now the y is. I don't know if that sounds too Star Warsy or what. But we switched those places. So now you have x equals 2y minus 4. At this point, we solve for y. We go back. We had y originally solved for. We're going to go back and do that again. So we do what we normally do, solve for that y, add the 4 to the other side, divide the 2 to the other side, and now we have y equals 1/2 x plus 2. What is that? That is the inverse relationship, or relation for y equals 2x minus 4. So the red dots on the graph, they are created by that equation, y equals 1/2 x plus 2. And we're wondering now, maybe why do we learn an inverse relationship? What does this do? The fact that it holds true in all three faces, the fact that it takes your outputs and gives you back your inputs, has a lot of bearing on what we do in mathematics, and another way to explain relationships. So we are going to take a look at our family of functions and find some of their inverse relations and see how they all connect. Mainly what we'll do is what we did with the equation in the third column. You will need to know, well, all the red words in the middle and second column, in the first and second column, and try to understand on all these faces how everything relates. Alright, so welcome to Inverse Relationships, and this will be our first step in understanding logarithms. Alright, take care, see you in the next video.